Okay, solving equations when we have rational functions. I'm sorry, Cody, I didn't mean to wake you up. You go back to sleep, my little baby boy. Yeah, you go back to sleep. Okay. And so one main thing that you've got to see a difference on is whether there is an equal sign or not. And I want to really emphasize the issue of the equal sign. Because if you go back to 5.1, I want you to see that there were no equal signs. So when you don't have equal signs, you're not going to be able to say this is what x is equal to. But now we do have equal signs. And the reason I'm pointing that out is because of how many times, and I've talked with other teachers about this, that students don't always know when they're supposed to give an answer like this is what x is equal to versus simplify. If there's no equal to sign, you leave an expression as simple as you can, but with the equal sign, you're solving. Now, extraneous solutions. The only way you're going to get extraneous solutions when you're dealing with rational equations is if you get a solution that makes an original denominator equal to 0, because dividing by 0 is a bad thing in math. So for number 1, if I get an answer of x equals 1, that will be extraneous. For number 2, there isn't actually a number that will make its denominator equal 0, so I can't get extraneous solutions off of number 2. Then if I look at number 3, 0 will make the denominator equal to 0, and if you factor a bit, you'll see that 5 does too. So neither of those are allowed to be solutions for number 3. So hopefully you're getting the idea with that. Now, if you have just a 0 on one side, save yourself some grief and add one of those terms to the other side. That'll save you pain later on, because you have to make sure that when you multiply both sides of the equation by something, that if you have any addition or subtraction between terms, you have to distribute that multiplication. But if I multiply over here by 0, it's just going to give me nothing. So the algebra is going to come out nicer if you first take and add that 1 over x minus 1 to the right. Now, the big thing is you want to multiply by denominators. Ideally, you want to multiply by the least common denominator, but you can do it in slow steps if you like. And you'll notice that sometimes I will write answers where I just do one big scoop of here's multiplying by the common denominator, and other things I'm going to have it more slowly brought out so that you can see different ways. So I'm going to multiply both sides by the denominator x minus 1. X minus 1 times 1, it's going to be x minus 1. On the right side, do you see what happens on the right side of the equation? You have a cancellation, because what you have is a multiplication by x minus 1 along with a division by x minus 1. So this factor that was going to be going up in the numerator cancels with this factor in the denominator. And if you need me to, I can write more steps in. If I wrote in another step then before canceling, I would look at x minus 1 is really just a fraction. And when I multiply fractions, I multiply the numerators and I multiply the denominators. And then you should be able to see that those two are going to cancel each other out. My computer's been weirdly glitchy all day. Starting with dropping me in the morning from period 1 as soon as I got started. That was a great beginning. You're probably thinking, please let that happen. Please let that happen. Less math, less math. Okay. So now I've gotten to the point where I don't have denominators anymore. And that's where you're going to solve this like you would any polynomial equation. I'm going to add 1 to both sides. And that gives me x equals 2. That is a solution as long as it does not make an original denominator equal to 0. The only denominator is x minus 1. It doesn't do that, so that is my answer. So, are you feeling okay so far with number 1? All right, then let's move on to number 2. With number 2, I have only one denominator here, and I'm just going to multiply both sides by that denominator. On the left side, there is nothing going on with fractions. So you could go ahead and just distribute the multiplication of 2 over the addition of x squared plus 2. On the other side of the equation, I do have fractions going on. And I'll show you a few extra steps that you don't have to do if you see the cancellation. This numerator that's sitting by itself is a fraction over 1. And when I'm multiplying two fractions, I multiply across the top and I multiply across the bottom. And then you should see that you have the common factor, x squared plus 2 and x squared plus 2. But for some of you, you may have seen that cancellation right away and gone straight to this step, and that's completely fine. I want you to do the number of algebra steps you need to do to keep your mind moving forward at the pace that works for you. And that means a different amount of work for different people. You have to put some work down. I've got to see what's going on in your head. Then I see only a single x out of this whole thing. If I see only one x, then my job is to isolate that x. So I will subtract 4 from both sides, then divide by 2. And when I square root both sides of an equation, what do I have to remember? There's a thing that you have to remember to do that people often forget to do when they do a square root. Anyone remember? Oh, could you? Yes, plus or minus. And also, Jason, the question you have, could you have divided both sides by 2 before distributing? You're talking about right here?
Yeah.
Yeah, you could have done that. There are so many different paths you can end up taking. You can, as long as you get to the correct number, you've probably taken correct paths, and that's fine. I can't possibly show all the different paths you can take, so if you feel good about your math, do it. So that plus or minus sign, don't forget about it. And then when I take the square root, I end up getting 1 divided by the square root of 2. And I feel perfectly good leaving roots in denominators. Oh, yes, I did not post the answers to the classwork. I was about to do that, but I had to choose between that and a bathroom break. So that's where I was. I will post these answers. Here are the first 2 problems and the work that I have for those 2 problems. And let me just kind of point out, and I will get this posted while you take a look at that. But I want to point out, I'm saying up here at the beginning, the only extraneous solutions are things that make the original denominator equal to 0. And then you can look at that. And I am going to get this uploaded. And it looks like I still need to put today's due date on there. Today is Wednesday. And just give me a second. I'm in the middle of uploading. That way you can look at the answers. And save. Okay. If you look, the answers were just posted into Google Classroom. So you can check your work if you want to be ahead of what I'm doing. Okay. Next problem. Now it's getting to be a little bit more. Anytime you see a quadratic in your denominator, your first step is to factor the quadratic, if it is possible to factor, that is. I want to point out to you that in number 2, I do have a quadratic denominator, but I can't factor that. You know, and to add on to that, also, I don't have any addition subtraction going on with number 2 on either side of the equation. That means that it's not going to be as difficult, that I can just multiply both sides by the denominator and not worry about factoring it. But in this case, I do want to factor it because it will end up making the problem easier. So this quadratic denominator, I can factor a common x out of that, and then x squared divided by x minus 5x divided by x leaves us with x times x minus 5. Now, if you're up for it, the quickest way to get through these problems is to multiply both sides of the equation by the least common denominator. If that's too much for you to do in one step, you can take one factor of a denominator at a time. In the answers that I have written up, I'm showing this one where I am just flat out multiplying by the least common denominator. So what I think might be good is right now I can go over doing this in smaller steps. And if you're ready for bigger steps, you can look at the answers that I have here that are posted on Google Classroom now. So I'm going to rewrite this to see it a little bit better. Maybe what you see is you have x's in the denominators. So if you want, you can start by multiplying both sides of this equation by just x. Now, if you see it right away, you can go ahead and cancel these x's right here. But you need to be very, 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 very careful about this subtraction, because you actually need to distribute the multiplication of this x over that subtraction on the right side of the equation. The left side does not have any addition subtraction of separate fractions or polynomial terms. So I'm going to rewrite and x multiplies by the x plus 7 over x, and then I continue to distribute it, and it multiplies to the 1 that is being subtracted as well. Some of you may see right here that you can cancel the x's. I'm going to put in a little bit more work just to make sure for those of you who don't see it. I can make x a fraction by putting it on over 1. And then when I multiply fractions, I'm multiplying across the top, and that will give me x. And I multiply across the bottom, which will give me x times x minus 5. For this particular fraction, you have a common factor of the numerator and denominator that can cancel out. The numerator will be left with just a 1 when you do the cancellation. On the other side of the equation, maybe you see this one a little bit faster, that this x and that x cancel each other out because I have a division by x followed by a multiplication by x. So I end up with just an x plus 7, and then my subtraction sign and an x. So now I'm going to see what we have at this point. I have 1 over x minus 5. On the right side, I have x minus x gone and just a 7. You know what? That question that I just saw in chat, why don't you square root the whole fraction? I realize that I need to go back and talk about that, and I will. And let me finish this problem, and then I want to talk about that question and make sure that everyone's clear on it. At this stage, I have a denominator x minus 5. When I cancel denominators, it has to be canceling with only things that are multiplying. The x and the 5 are subtracting. That makes them a whole unit that can't just disappear. They are a team that has to stay together. They can only cancel with another x minus 5. And I start the process of multiplying both sides by the denominator, x minus 5. And I'm doing that on purpose to make these two cancel. On the left side of the equation, I have a 1, and on the right, a 7 that we'll need to distribute over the subtraction. And then a little more footwork and we will have an answer. Add the 35 and divide by 7. Sadly, we are left with a fraction that we cannot reduce and isn't as pretty as we might like, but it is an answer. And it certainly is not a number that's going to make an original denominator equal to 0 for that problem, which we can see right up here. Now, before I start 4, I want to go back to the square root issue because I realize I did that too quickly. So I'm going to erase this and go back to this step. As I'm isolating x squared, I'm going to divide both sides by 2. And then when I take a square root, I am square rooting the entire both sides. And one thing you want to remember is that square root is going to distribute over division, just like an exponent distributes over division. And I get the square root of 1 divided by the square root of 2. The square root of 1 is 1. So this is what I skipped. I went too quickly to that answer. So I actually did square root the whole thing. I just didn't show the work that I needed to show for you to see that. Okay. All right. Let's take a moment without math because it gets tiring doing algebra constantly. How's your day going? Managing? Have you been glued to elections or annoyed and absolutely sick of it and over it and want it to go away? Yes to both. Yep. Some people love going through the drama of elections. I've got to say it's one thing I don't look forward to every year because it does end up being a lot of drama, especially when it's the presidential election. Those are always dramatic. This year's a little more drama than others. And I even spoke with my mom, and my mom agreed that this is, and you know, she's been around for a few more elections than I have. And she said, yeah, this is about the most emotional election she's seen. So, yep. Okay. All right. Talking about elections, does it make you want to do more math? Makes me want to do more math and less elections. So here we go. Back to math. Number 4. What you want to see is take a good look at the denominators. We've got a linear denominator, ooh, a quadratic denominator. I want to factor the quadratic denominator. It might save me time if I do. And I am looking for 2 numbers that multiply to make 8 times 1 and add to make -6. What are those 2 numbers? What will multiply together and give me a positive 8, but when I add them, I get a -6. Yep, -2, -4. And what do you know? There we go. And you notice that that happens to be the denominators we already saw. So that means that I am going to save myself time by multiplying by a common denominator. Would you like to see me multiply in one swoop by the entire least common denominator, or do you want me to take it one at a time? Because I can do either way. Or I can go with multiply by the entire common denominator, and if I lose you, I can go back and do it more slowly. Okay. So when you look at these three denominators, the least common, the greatest, what am I trying to say? The least common denominator, that's what I'm trying to say, is x minus 2 times x minus 4. So I am going to multiply. Hi, my glitchy computer is driving me crazy. So I am going to multiply both sides of this equation by x minus 2 times x minus 4. I'll write the factored form. Some good news. This section will be the last of learning new algebra. I only have 2 classworks for this chapter that focus on algebra. And then I just throw a little bit throughout the homeworks and focus the rest of the homeworks on graphing issues. All right, now, very, 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 very important. This addition sign, I have to distribute the multiplication over that addition sign. That's the thing that people tend to miss when they're solving these equations. I have restarted my computer today. I have turned it off, let it cool, turned it back on again, and it's still glitchy. So I do not know. Okay, I'll try doing that later today. So this plus sign, and I want to emphasize it, or some percussive maintenance. Oh dear. I'm still multiplying the left side out. And now I'm at the point of this equal sign. And I'm going to save myself a lot of writing if I right now realize that I've got a big giant cancellation going on. And I now have absolutely no one I can see. I see a lot of circles. So hopefully you have not completely left me. Okay. All right. We got people. I'm multiplying, or I'm canceling the multiplication of the x minus 2's and the multiplication of these x minus 4's between the numerator and the denominator. I am left just with the 2. Then before I start the next line, I want to see what I can cancel between that addition sign. To the left of that highlighted addition sign, this denominator will cancel with this x minus 2 that is multiplying. To the right of the addition sign, this denominator of x minus 4 will cancel with this multiplication by x minus 4. At this point, I have x minus 4 times the x that's in that numerator, and then that plus sign, and x minus 2 times 1. And I'm just going to over-exaggerate that. And then my equal sign and 2. And now I'm at the point where I have a polynomial equation, and you have been doing this. So I'll do that a little bit faster. Distribute the x over the subtraction to get x squared minus 4x. And I need to subtract 2 from both sides of the equation so that I get my polynomial set equal to 0. And while I'm subtracting that 2, I'm going to bring together my like terms. I have a ln x squared. Negative 4x plus x gives me negative 3x. And then negative 2 minus 2 gives me minus 4. And I'm back to factor fun. I now need to find a times c is going to be negative 4. B is negative 3. I need to find two numbers that multiply to give me negative 4, add to give me negative 3. And what are those numbers? What will multiply and give me negative 4, but when I add, there we go, negative 4 and 1. And if I have my polynomial factored equal to 0, then I can look at what makes each individual factor equal 0. And that gives me a positive 4 and a negative 1. But before I say this is my answer, I need to make sure I don't have extraneous solutions. So I'm going to go to look at the original problem. Do either of these two answers make one of those original denominators equal 0? Yep. 4 makes it 0. It's an extraneous solution. That means my only answer is x equals negative 1. And it is possible to get no solution. So that is number 4. I have 2 of these left. And you are probably tired at this point of algebra. So let me ask you, do you have any questions? We'll take a short break and then finish these last 2 problems. That short break would be, do you have any questions on yesterday's homework other than my failure to put a graph there? Are there any questions on yesterday's homework? Yes. Yeah. And with that, it's all about graphing the parent function. And I'm not giving you problems like 2 and 3 from the homework, but just the ones where we're graphing. Okay. Do you need a stretch break? In other words, let's stretch a little bit. We could pretend we're polynomials. Go, ah! Or do disco. Because I know it gets a bit tiring to just do algebra straight and just keep doing it. You need to stretch a little bit, clear your mind. Blah, 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 blah. And are we ready to keep going? Are you with me? Is your brain ready to think? All right. I've got one, maybe two, I don't know. For number 5, do you see that there's only one denominator anywhere, and it's x minus 3? So I'm going to multiply both sides of this equation by x minus 3. I have to make sure when I do that I distribute that multiplication over this addition. You can do this as quickly as you see the next line. You don't need to write as many steps as I'm going to show, because I'm trying to make sure that I don't lose anybody, like I did on problem 2 by accident. So I'm writing the left side of the equation and multiplying it by x minus 3. And I also need to multiply the right side by x minus 3. I've got to be very, very careful. I have this addition sign. And I'm going to distribute the multiplication of x minus 3 over that addition sign. On the right side, you don't have an addition or a subtraction between terms. You are ready to just cancel those two. On the right side of the equation, that leaves me with 2x. If I said no, would I let you leave? I just read that. Yeah, no, I don't let you leave. In fact, oh, you know what's great? Not great to some of you, but great for us as teachers. If the internet drops you and you come back on, ultimately we end up seeing how long you spent in class. So if you spend, like, let's see, I think one of my winning low numbers was 12 minutes. If you spend a very short amount of time in class, that's where I write down that you were not participating, or what's the word they use? Anyway, engaged, that you were not engaged during synchronous instruction. So I can look at that and get quite a bit of information. Although when I look at circles, I do question, are you actually there at your computer? Or did you wander off somewhere because you don't want to have to sit around and do math? Oh, yay! People are here. Okay. Now, as I get going on the next line, I can save myself some time if I see that these are going to cancel. And then I'm out of the problem of denominators. I don't have fractions anymore at that point. I have an x minus 3 times an x, and I can distribute the multiplication, giving me x squared minus 3x. Over here, I have a leftover 6 after this addition sign. And then on the other side, I have a 2x. Now my job is to make one side equal to 0 and bring together like terms. I'm going to subtract 2x and have negative 5x. And now it's factor time. Yay! I was looking forward to factor time. It's what I live for. A times C gives me 6. B is negative 5. What two numbers multiply to give me 6, but add to give me negative 5? Multiply to give me 6, but add and give me negative 5. Yay! Negative 3 and negative 2. And that gives me two answers. X minus 3 is 0 when x is 3. X minus 2 is 0 when x is 2. But before I call it a day, I need to check them. Do they make an original denominator 0? Do either of them make an original denominator 0? Well, I'm glad we can be mildly entertained. Okay, yes, so 3 makes an original denominator 0. My only answer is 2, and that problem is done, and I only have one more. One more. And then I can send you off to the quiz and send you back to either election results or ignoring election results or doing homework. So I'm sorry. All right. Now, for this one, do you want me to go forward by multiplying by the least common denominator? And then do you see what the least common denominator is? I've got an x, and I've got one here and here. What other factors do I have that make the least common denominator? I do have an extra factor of a 2. And then what is the other denominator? X minus 1. So the least common denominator is 2x times x minus 1. And if I multiply both sides by that, I'm going to get through this fastest. And I want to say again, be very, very careful about this addition sign. You have to distribute the multiplication of that common denominator over this addition sign. When I do that, I will have a 2x times an x minus 1 times x over x minus 1. Yay! Then that plus sign, and I continue to distribute. So I have 2x times x minus 1 times the 3 over x. And let's save a little bit of time and do some canceling. The denominator 2x cancels with the multiplication of the 2x over here. And that will leave me on the right with a 5 and an x minus 1. And if you want, I'll go ahead and distribute the multiplication of 5 over that subtraction. And that will be 5x minus 5. After going through the distribution property, I'm ready to do some cancellation. The denominator x minus 1 will cancel with this multiplication of x minus 1. The other denominator of x will cancel with this multiplication by x. And now I need to sift through the ashes and see what's left. So I have 2x times another x. Over here, I have a 2, a 3, and an x minus 1. And on the other side of the equation, I have a 5x minus 5. So now it's just a game of let's play polynomials. Yay! Distribute the 6 over the subtraction. Make one side equal to 0. Subtract 5x to get 1x, add 5 to get minus 1. And now I need to figure out how to factor this quadratic. You okay, little doggy? My dog is getting restless. Okay, so when I make the diamond, I'm looking at a times c is -2, and my b number is a 1. I need two numbers that multiply to make -2, add to make 1. Oh, Jason, you're beating everyone. So oh, good. Okay, so if I use -2 and 1, they will multiply to give me -2, add to give me 1. Do you want me to take you through the rest of the factoring process? Jason really said you want to see some real speed. Do you want me to take you through the factoring process with the box? If you don't say yes, I'll assume no. When I factor this, okay. So we did the diamond to figure out how to split up the x term. It's going to split up as a -2x and a +1x. And then we put the squared term in the upper left corner and the constant term in the lower right corner. Then I've got to figure out, is there something that will divide both 2x squared and 2x? What will divide both a 2x squared and a 2x? What can I factor out of them? A 2 and an x. Then I can look right here and go, what do I multiply 2x by to get 2x squared? And that would be x. And this might be working. What do I multiply 2x by to get the -2x? -1. And then x times what gives me x? 1. And does that work for the last box? -1 times 1 is -1. It does. So that means that this is the correct factoring. I have a 2x plus 1 and an x minus 1. Then when I solve for each factor being equal to 0, after subtracting 1 from both sides, I have 2x equals -1, giving me a -1/2.
Wait, it's Blanchard.
Yep.
I thought we had to make negative. Oh, never mind.
Okay. I get two answers. The question is, are either of them extraneous? Do any of them make an original denominator 0? And I've got an x minus 1 denominator, so that one isn't going to work out. But the other number does work out. All right, so there you go. That was some fun algebra, and I am going to release the quiz. Who's excited? Who's excited to have the quiz released? Maybe. Copy. As soon as you're done with the quiz, you can take off. And again, it's just on the graphing that we kind of spent 2 days on that graphing, so it shouldn't be too bad. Push enter. There you go. Enjoy. Have fun. Hope your afternoon isn't too painful.